Okay, so we are going to do some function stuff here now, right? I have this function negative 3/4 x plus 1/2, right? So we're going to take the two different cases that we have. One is when we're given an input and we got to find the output. The other is when we are given an output and we're trying to find input, right? So it's very important that we kind of understand which case is which, right? So for A, we have here, let's put the right tools, okay? We have here something inside of our notation, right? Instead of an x, I have 8/9. That means that everywhere I see x in my equation, I replace it with 8/9. Here we are given an input and we need to find the output. Okay, I'll try to clean up my handwriting with some practice as the videos go on, right? So here I'm given an input. I'm given that my value is 8/9, right? X equals 8/9. Okay, but f of 8/9 equals what? That's what we're trying to answer. Okay, so if I come over here, f of 8/9 means that I have negative 3/4. Remember, a negative is the same thing as the top being negative, right? I'm plugging in 8/9, and I'm going to add to that 1/2. Okay, so I chose this number on purpose because it's nice. Here I can see that 8 and 4 cancel. I'm left with 1. Here I'm left with 2. 4 goes into 4 once. 4 goes into 8 twice. I also have something that cancels over here. These are both multiples of 3. So this negative 3 turns into a negative 1. This 9 turns into a 3. Right? So what do I have left over? Negative 1 times 2. 1 times 3. That gives me negative 2/3 plus 1/2. There's no more x here because I plugged in 8/9 for x. That's what I just did. I just plugged in the value. So now I'm just really adding fractions, right? I need to turn these into something that has a common denominator. We do that the same way we look for LCMs, right? So I'm counting multiples of the biggest number until I find the number that both go into. This happens to be 6, right? So I need this to be a 6 on the bottom, and I need this to be a 6 on the bottom. So I multiply what I need in order to make both of those 6 on the bottom, right? So here to make it 6, I gotta multiply by 2. I gotta do that to the top also, right? Here I need to multiply this by 3 to make it 6 on the bottom, so I multiply the top by 3 also. Minus 4 plus 3 minus 1/6. Okay, so if I plug in 8/9 into my equation, I'm going to get out negative 1/6. Okay, so then let's do the second one. Okay, so for B, if we look at the notation, I don't know what x is. In fact, it's asking me what is x, and I have something given to me on the outside, right? So here in the notation, the number I'm given is inside the notation. Here the number I'm given is outside the notation. What do I mean by notation? F of x. F of x is my function notation, right? That's how I write functions. My function is equal to 5/3. So here I'm given an output. So I need to find the input that goes with it, right? I know when I plug in something, I don't know what, I'm going to get out 5/3. Okay? So, I can do some math to figure that out. I can set this up. 5/3 is minus 3/4 x plus 1/2, Alright, we'll be working on this equation. And again, now I have an equal sign, and I got numbers on both sides of my equals, along with fractions, so I can clear denominators, right? So I'm going to find the LCM of all the denominators I see. And I'm going to count by the biggest number that's there, 4. So the first number I count by is 4. This works, this doesn't, this does. The next multiple of 4 is 8. This works, this does not, this does, so it's not going to be 8. The next multiple is 12. Okay. And all of these numbers work with 12. Okay. So again, my LCM is 12 here. So it goes on the top of every number. Okay. Multiply by 12. This is a minus 3, a 4, an x, and a 12 over 2. And again, it's these numbers that I'm trying to get to cancel. Okay. 12 over 3 is going to give me 4. 5 stays there. 12 over 4 is 3 times the negative 3 that's there already. And there's an x plus 12 over 2, which gives me 6. Okay, so I'm going to clean this up real quick. Okay, so I rewrote the multiplying by 12 and the canceling part, and then I rewrote what we had left over, right? So we can start to try to solve for x, because it's the only thing I don't know. So I can start to simplify these and move things over. 4 times 5 I know is 20. 3 times 3 is 9. And the negative there, right? One positive, one negative. So negative 9x plus 6 times 1. And again, my goal is to get the x's alone and all the numbers over. So I will subtract 6, subtract 6. Okay, that's what I have left. Negative 9 on one side, because these things go away. 20 minus 6 is 14. So that leaves me with x equals 14 over negative 9, because I got to divide both sides by 9. And really what we want to do is we want to think about this as negative 14 over 9. Although where the negative sign doesn't matter, top, the bottom, or the whole thing, it's a negative number. Okay, thanks.